Hi, crafty boy. I'm writing a program to analyze how to optimally give mate with a rook, king plus rook versus king on a quarterly infinite chessboard. In particular, very far away from the corner at the moment. This is MS6. Oh, that's all the yeah. Well, yeah, not an infinitely large. Well, it is infinite large, but we have a corner. Otherwise, you can't give mate. So like this, there's a corner here, and then the board is infinitely high and infinitely wide to that side. Only one rook. Oh yeah, from any position. Doesn't matter where our stuff is. You can always give mate. Let me see. I have here 1, 2, 3, 1, 2, 3, 4, 5. Why do I have so many here? 1, 2, 3, 4, 5. No, what? I can't count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So it's both for black and white to move. See if n is not large enough. If it is larger than 8 or equal, then it's with a fixed m. M is the distance from the number of empty rows till the edge under the rook. And n is the number of empty columns to the edge from the black king. In this position. Now, if there are not enough columns, then it's not a nice formula. But if n is large enough, and well, for m is 6, so in this case we have 1, 2, 3, 4, 5, 6 empty rows, and then this whole position is being shifted to the left. So in order to increase n, yeah. So you can put it here, or you can move the whole thing to the right to increase n. Then you must have at least n is 8. I mean empty columns, so that's already larger than a normal chessboard. Before the formula stabilizes. The number of ply in which you can give mate with black to move is 28 plus 2n. So then it's just always 2 more ply if you shift the whole thing 1 file to the right. Right now I'm only interested in big N and M. So I forget everything before this. It's just too small n. So I only take the formula, put all those formulas for when n is large enough in this table. Therefore, I don't even have to print this. Let's not print this. Who is printing this? Something that's printing this, or something that's... I think this is being printed. Yeah, I need to run this function because it returned something. So I guess suppress. I return a final K, so after I calculated that, I don't have to execute anything, only. So we can, we don't have the calculated groups either, it seems. So this print thing is now just returning the final K value, meaning the K value of my formula, so 28 in this case. I'm gonna run it again to get more inspiration. Oh, wait a minute, before I do that, let's also suppress the playing mode. Execution time. Yeah, the table is printed, and then we have the moving. You can just do return 0 there. I think now it prints multiple tables. And suppose I should put everything in one table. Yeah, boy, there's still a lot of empty lines. So there's not much reason to repeat all of that every time. I could just put MS2 here, maybe in front of it, and then split it up. I think in front of this, no. Let's keep all the black to move together. Now, strangely enough, you can put the kings anywhere. If you put the white king in the corner and the black king far away from the corner, then you would say you cannot give mate, but you can. At the moment, I'm not really concerned with that though, because I'm going to assume that everything is more or less close together. Yeah, for the longest time I thought that it was not possible to give mate if the black king escaped, as it were. But you can just put the rook far away, cut the black king off over one line. And then the black king can only run away from the corner along that line. While the white king then walks diagonally away from the corner. So it can't overtake the black king in the direction that the black king is walking, but it can arbitrarily far overtake the black king in the direction perpendicular to the line that the rook is occupying. And then you just switch. You put the rook on the line perpendicular to the previous one, and then the king is far ahead in that direction. So now it has time to overtake the king again perpendicular to the rook. And then you have you just overtake the black king. Then the white king is further away from the corner. And the reason being that you can force the black king to walk in a straight line while the white king can walk diagonally, which is basically every move you do 2 moves. 1 move up and 1 move to the left, all in 1 move, to the right I mean. Because you step diagonally while black can only do 1 at a time. That's why you can overtake it. But yeah, you have to do that, and then once you overtook it, so you can really cut off the black king in a rectangular. Let's say the black king is now inside the inside the rectangle that is cut off by the real corner and the rook is protected by the white king. Then you have this kind of positions. So here the rook is here and the corner is here and the black king is in that rectangle. And the white king is protecting the rook. So the white king is just anywhere here to protect the rook. But okay, this is only where the black king is attacking the rook. Therefore the white king has to protect it. But there are some other possibilities, of course, like the rook is far away and the king just takes. I mean, I don't know how to say it in word, but you get it. So there are multiple positions like this. You can only give stalemate in the corner, so that is neglectable. And it never leads to needing to do more moves. You just avoid it. It was pretty irrelevant. Well, maybe if you have a beginning position where the optimal move would be theoretically one where it would be immediately stalemate. So you have to first do a move in order to allow black to move. Then it could be one with a 2-ply more, I suppose. But then you already begin in a stalemate position, so you can hardly. Well, stalemate position with white to move. Okay, what I want to do here is print, rather not print this, but collect everything. So I'm having here y to move final k values for a particular m value. So I want to make this a vector where I can just pass m. And let's make this a vector as well. M as index. Then we have to move this now outside here. Make this a standard vector of a standard vector. With a size equal to the maximum value of, well, one more than the maximum value. So it's 7 in this case. Let's call this mint. And then mron still mint. Now we're collecting everything. And then I don't have to print this here, but we can move this outside the M loop. We just have to do the loop again, but let's say we first calculate everything and then we print it. Still printing the same thing. What is this endiv? It is just instead of doing this. This is not really interesting anymore, I think. Use the first legal position with the right rook on the board. Yeah, no, let's not do this at all. And then you have use initial position, initialized above. With the position that is made in the maximum number of ply. Okay, so we had already an initial position here. Which I don't even have to calculate actually, because I'm not using, I'm not doing any moves anymore now. What do you mean, where do you learn to build this? Huh, what? If you say build, I think about building CMake. You mean design this, write this? I didn't learn anything, I just do it. I'm on Arch Linux. Okay, so let's make this one table where the M is 2 is a new column. Maybe do that first. Probably should just remove the +2n as well. This is just the k value of the formula. So So I want to print a header, not this. And then of each of the M values, the black to move thing. And then for each of the M values, the white. Though the M goes in a column in between here. M in the column in between. Okay, let's do that step by step. So first, the not printing M equals means that we just do this, print it, and this is then my header. Which you can print before the loop. And I need a new column. Why is that not working? Do it this wide. This should not have been a cross. Is this bold? I don't have that yet, I think. Let's find that character. So the bold T is what I need. Like that. And then this column here contains M. I think that should work. Okay, and then what is this doing? Black, 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 black. So that comes there, and that must be followed by the value of M. As in a space followed by M, followed by a space, followed by a bar. So that would print this part up till here. Damn it. And then, well, here, one lower than that. And then we print the formulas. That's this part. And then we want to print the white stuff. But now we have black, 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 black many times, which is not very nice. Let's do that only when M equals Mn divided by 2. N equals M end divided by 2. Then print black, otherwise just print an empty thing. BLACK and that thing. Okay. Yeah, we need the closing stuff as well, which is now shifted to, suppose, was that lined up with something? It's indented. It's kind of slightly annoying. Let me indent this. Well, no, let's indent it here. So this thing lines up with that, and this lines up with that, and so on. And this must line up with that. So this must be over there. And then we have here a new heavy bar. So one of these things. And I need to add my... Okay, now I need a heavy bar and a thin line. I don't have that yet. Yes, I do, here. Now this one aligns over that, and this one lines over that. That's good. And then here I do again space. Yeah, we should just do set width here. Actually, let's not do this space, which I also don't have here, by the way. Let's do here standard set width 2. What? And then we print this. And then we have the closing stuff. I guess and we need more here. What the hell? This lines up, okay. And then here we need 2 thick thingies. And this I'm pointing up. This one. I think that's about it, right? Let me try this. What this gives. Question 1, does it compile? It compiled. Question 2, how does it look? Almost, but absolutely not correct. Yeah, for one, I have to do the black one first and then the white one. And apparently there's something missing after the second thick bar for the bottom. And I need to do all the blacks first. No, let's be lazy. I think this now has to go outside of here. No, what is this? What is this? This line makes no sense. I'm gonna put this here. Well, almost. Black is missing a new line, and there's also a new line missing before the end here. Oh, that's the one that I deleted. I would have put it one higher. That's just like here. And that would also be the new line then. And in the case of black here, we have a missing new line. Why? Where? Print chat. Out. Oh, I put it here accidentally, I think. Or, oh, no, I'm confused. Printed, yeah, it must be here. And this one, oh, actually should be here. I don't know what I'm doing. Just try it. Gets at least closer to the correct one. Right. Well, that ain't right. If the values are 2, 3, 4, 5, and 6, then the best place to put white is here, not there. And this 4, of course, is something divided by 2. Probably just begin plus n divided by 2. I shouldn't begin to be 0 the way I did it now. Same thing here, so there must be begin plus end. And white is still printing these things here instead of, well, instead of this. This is not printing any line whatsoever anymore. Too difficult. Okay, so begin present. And it's this one. Iterative programming. Now that's what I wanted to see. Next, let's remove the two in. Yeah. Now here you can see that, let's say we are here, that is white is to move, and this is the position. Then if white doesn't move, then we must end up with 8, 1 ply less. And that 8 is this one. Meaning that white has to move the king 1 down. Then you get this position with black to move. But it's not clear where to go from there, because, yeah, black is only in the corner of the rook. So we don't have any possibility to even investigate where that would be. So I think that at the very least, all these 5 has to need to be regenerated again with the king moved there, there, or there. So times 3, then you get 15 in total. Which then includes all possible moves for black, so that would be good. Then afterwards there are still other possibilities for white. From those, I mean, you do not have to allow the black king to go back to the rook, attack the rook again. Not to mention, well, if you do that, then it would be white to move, and then you have this position again. But you can also keep the black king from going to that position by putting the king here or there. Which are currently completely missing. See if there's another one. For example, this one with white to move. What is the best move? Let's say for this one, 31. Well, that should be one with 30. You do one move, and then black is to move, and then it should be 30 ply. And well, 28 is less, but well, it's not one of these, and 28 should not be reachable, obviously. Otherwise, this would be 29 instead of 31. Meaning we cannot go from here to there. Yeah, that's true. The king cannot go 1, 2 down. The king has to go 1 down. Then you go from here to there, and from here to there, for example. Let's see, where say, and the M stays the same. It has to be the same, of course. And that is nicely visible from the fact that this is 12, 12, 18, 18, 22, 22, 26, 26, 32, 32. And this is one more. Yeah, this is equal. Oh, that's a M is too small there. These are equal, 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 equal. And here we have 2 less, 2 less, 2 less, 2 less. And here we have again 2 less, 2 less, 4 less, 2 less. What the hell is so special about MS5? Why? Very special case there. Here too, by the way. These are equal, equal. This is 2 more. So maybe this is the problem. This was also equal, so this was 26, and we have to subtract 2 going from here to there. Then this is 24, and we have to subtract again 2. Then this is 22, which is correct. So really the problem is that these two are too high, which means that there is still no fixed structure. Maybe M has to be at least 6. Which would it's kind of necessary to calculate way more M's, I think, like 7, 8, 9, 10 at the least. I don't have enough memory for that, damage. I need a board of 32 by 32, which is way too big. Arg. Or I can try to do... No, I cannot. And N must be increased as well, I think. I probably should add the minimum value of N as well, because it's now a bit unclear. This is for arbitrary large N, but I don't know anymore how large. It has to be at least. Could add it in this column also. So M is 2 and N is greater or equal da da da. Add another column for N, or let's say N comma M, I suppose. Let's put a column for N in front of this, and then just do N is greater or equal something. And we have that information as well. Yep. So I must print N in front of this. But it's not just N, it's the maximum N, or the final N, the maximum final N actually. Max final N, which is again a function of M. But this is with black to move. Okay, how do we get those two vectors? This one, I mean. So you already have calculated the final k for a given m for what the hell? For black, yeah. So we need to keep track of the maximum final k here. For black, so I could do that m becomes final k if final k is larger than current value. Yeah, but also if m is the very first value. No, that's nonsense. This, if that is 0. And then again for white. So this value should be like 6, 7, and 8 ish. Probably only 7 and 8. Holy, what? 14? No. Oh, final K, my ass. That's not what I... No. Wait a minute. Yeah, this is the largest final K. This is final K, so this is the largest one. 22, 28 is the largest one, 32 is the largest one, and so on. So, well, it sort of worked in that sense. Not what I intended. It's called final N, man. Final N, not final K. So it's the N that belongs to... Oh, where do I have that? I think I need a print formula table to return that. It's the end value that belongs to the final K. So if this now returns final n value, and then we just say the largest final n stored in the max final n. So this must return a standard pair int 2 ints. And then we need to figure out what the final n is. That belongs to the final k that I find eventually. Oh, that is stable n. I think I update stable n. Stable n minus minus stable n equals n. Final k is previous k. I think stable n is just updated. Yeah. It would probably be better to call this table n as well, otherwise the thing has just different names. Yeah, I could well this file wide. Don't know, file wide search replace. I'll still do that. So final n becomes stable n. Where is standard pair defined? No clue. No clue whatsoever. Utility. Yep, 7 8. Right, let's extend these positions. Then we should how to encode that. I want a center dot. So this was canonical one. The king is always at coordinate n. Therefore, if the king is one step to the left relative to the rook, then the rook is at n plus 2. And if it isn't, then it's at n plus 1. Down here again, it's n plus 2 and n plus 1. And the bottom two, the king is also moved down or just moved down. In this case, it is moved to the one here and one down, and the rook is always at m. So now this is m minus 2, and this is m minus 2. And the white king is not there. The white king is at most there, I think. The same thing here. But in this case, the king is not even looking at the rook. We probably need king here as well as a position. And the king here as a position. And here and here. Yeah. I think you have to do an attack in Clash of Clans, so I'm gonna stop. So I'll just quickly do this one. I don't know what comes out of it though. Let's call this delta. White king delta x, white king delta y relative to the rook. Relative to the rook. That must become -1 if relative to position is 4. So yeah. But it's relative position mod 5. does this make sense? Well, the first one, what the board takes first blacking position. So blacking X, square, blacking X, blacking Y. And then the white king, which is calculated as relative to the rook. So the white rook X plus the white king delta X, the white rook Y plus the white king delta Y, and finally it takes the rook coordinates, white rook X and white rook Y. Then those delta X and Y are relative to the rook, which means this. So WK dx must be -1 if relative position index mod 5, which is VK pos, is 0. We take the minimum of VK pos and 2. So if VK pos is 0, then this is 0. -1 is -1. That is correct. And then if that modulo thing is 1, then we get still it's still less than 2. So then this is 1. -1 is 0. So yeah, then we don't change it, and the x coordinate is the same as the root coordinate. If it becomes 2, then we get 2 minus 1 is +1, so then it's on that side. And if it is 3 or 4, we still have 2, so it remains 1. And the WKDY must be +1 if it is 2. And we get 3 minus, well, the max of 2 and 2 is 2, subtract is 3. And then if you make it one larger, then we get the maximum of 3 and 2 is 3, so that becomes 0. And if this becomes 4, or this becomes 4, then this becomes 4, then it's -1, and we are 1 lower. Well, if it is 0 or 1, when we stay in this column, then we still have subtract 2 is 1. So that's correct. And then the white rook X coordinate is n plus 2 in this case. And in this case, minus BK pos, which is the relative position divided by 5, modulo 2. So if the relative position divided by 5 is 0, modulo 2 is 0, then we add 2, then it is n plus 2. And that is correct. And then if it is 1, mod 2 is 1, so then we subtract 1. Subtract 1 here. So then it becomes n plus 1, which is this one. And since it's mod 2, then we get n plus 2 again, and then n plus 1 again. So that's correct as well. That was this one. Now the y coordinate is per definition m for the rook. Always. The black king x coordinate is n per definition. And the y coordinate is m minus 1, m minus 1, and then m minus 2, m minus 2. So that is the BK pos divided by 2. So 2 and 3 we get minus 1, so it's m minus 2 in total. And otherwise we get m minus 1. No mistakes. Let's see. Well, we only do 5 things. So this is the king. The black king is now moved to the left 1 position, which we can't print anymore. All the values changed, but we're not printing it actually. This is just fixed header. Plus, I wouldn't be able to print it because we need more space then. I need to make this now a 4x4 thing, and then have some function that can print this as a 4x4. Yeah, the k values that are printed are stored as a function of an. This is a vector by itself. So they are stored in a vector. And the index of that vector is what? Push back. This pushback happens for relative position, running from 0 till. Guess that's how I'm going to treat it. Let's introduce something else and a hard-coded 5 here. Let's call this relative position int. use prefix. Or say, I call it separator. Separator is this, so we print that. Then, well, here anyway. Oh, that's not good. Boom. So for each row, we first print a row header, which is this part up till there, and then we print the separator, which is this thing, and then we print a relative position line. That is one line of the position, given the position and which row. And then we change the separator, so we go to the next one, and then we print this one, this and 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 this, and so on until we leave this loop, and then we print this, and then we do that again for every row, and then you have the whole thing. And every column must be one wider now, because there must be 4 wide. 2, not only that. And now I have multiple columns, many columns. Not just 5, but a lot. Yeah, it's just a lot of work. I'll just have to type it, I'm afraid. A lot of work. I'm going to turn that into a function, separate function. And I'm going to do that after first fixing what I now changed, so that it's not do it yet. I need to write this on. Let's begin with creating this board. And an M just must be large enough of 3, I guess. I currently have a -2 at most, but it might become -3. Let's put it at 3. Yep, then I think I want to put a rook at row 1, column 2. So we have some board, but I want to print it as, try the rook here. And say a dot in the corner here. Doesn't really matter that much. I'm gonna make this a space, and this is space. So a delta x and a delta y, which is, let's say, from row, let's call this colon here. To the axis from the col plus dx equals the x coordinate of the hoek, or the hoek x. And same thing here. Well, the col of the rook, so that's 2. Yeah. I'm going to do the conversion exactly the other way around, as in we add it to. I mean, that was the same thing, but no. Well, let's write it like this. What a horror. It's upside down. It's not a horror. It's perfect. But in the R isn't the correct position, but it should be mirrored in this line, vertically or horizontally. How do you call that? I think it makes most sense to just invert this definition. This is numbered from 0 to 3. There. Yep, perfect. So now all of these lines should become wider. So let's print all those with yet another function, as in Yes. Okay, how often do I want to repeat this? One less than the size of this, right? So 4 times, this case. But I forgot one thing. What? 1, 2, 3, 4, 5 characters. Okay. So yeah, maybe I need to make them wider, so I should not pass this, I think. Let's just separate it. How many line pieces do we need? One more than 2 times. No, this is the 5. One less than 2 times the width of my square, which is given by, which is hard coded. That hard coded so hard that it's nowhere to be found back. dang. Might want to increase that as well. Let's try to make a const expression for that. Int relative position width. And height. And then at the very least my count should become two times that minus 1, I think. Test that out. Almost. So this thing is 4 wide, but I clamp it against this line here, and as well as on the other side, even though a square is actually 2 characters. So that's the minus 1. Let's say if this is 1 square, I mean either this is 1 square or that is 1 square, I mean depends on how you look at it. It's more like actually if this is the center of a square, then it's like half a character. So like not this, half of this character plus the k plus half of the next character, which is exactly to the middle of this line. So if the line was infinitely thin, then it is actually a square here. So yeah, but the total number of characters is then 2 times the width. The width being 4, so that is 1, 2, 3, 4, 5, 6, 7, 8, minus 1, because you don't want to erase the bar, as it were. Is this just too long or what? The rest seems to be lined up exactly, and then we have a problem with these things, but yeah, I guess I just forgot those. So just the top line seems to have something that is too long there. I don't understand why. Top line, we'll find that back. What is this one here? One too many. And then while printing the formulas, that was actually not printing formulas anymore, we print the k values. It's no longer visible where that happens. I think here. Yeah, here. Yeah, there's a k value. Final k values. I'm currently printing that as a width of 4 plus 1 space. And now it's wider than that. I guess 2 wider. I'm just gonna add space on either side. Yes. Okay. Now it should be easy to extend this to many of these positions, which is not going to fit on my monitor anymore, which is going to make a mess. So it's going to be 4 times as wide. Well, I can make my window another monitor wide. Let's just do it. I guess I can just set this to 20, and then we have all 24 volts. Yeah, that should work. Just make my monitor. Well, I'm gonna set the font smaller, I think. Yep, and then it fits. Now, do those positions look correct? So yeah, that's the same position where the white king rotates around the rook. And then the king is put here, the black king attacking the rook. White king goes around it again. And then the black king is put there, white king goes around, and then there, white king goes around. And then hopefully these numbers belong to that. Oh, there's a suspicious 17 here, which is definitely not correct. Dang. And a minus 31, yeah. Okay, so this one breaks down here. For m is equals 2, and why to move? Why? Weird, man. Why? Why? I think you can kind of deduce what it should be. The minus 31. Because white is to move here, right? Which means that there was a position before this one with black to move, and then black went down, which isn't the worst move, I think. Or is it? Actually, it is pretty bad. Yeah, he should not go down. I mean, if the king was here, then it should probably move there, not down. Or, yeah, that would be made in 2. So just a really stupid move. Then the white king goes here, and then the black king cannot go there because of the rook and cannot go up. So it has to go there, and then you just give mate. So this is insanely fast mate, which is not working for large n, because we just assume that this is minus 31 plus 2n, and n is just arbitrarily large here. Well, not arbitrarily, but as large as what I'm doing, what I'm using for the calculation under the hood, as it were. So you see that this is made in 1, 2, 3 ply. So the formula is 3 equals minus 31 plus 2 times n. Therefore, n is 17. Yeah. And then the stable n must be 17 because it's all on its own, not having anything to do with the rest. Yeah, I think you understand this one. The problem with this one is simply that it's a super bad move of black. As not on this plus 31, which is maybe normal. That is not necessarily bad. I think those are all small kind of. It's a strong indication that calculation went correct for every other move. There is no other move, also no other position that is this bad, right? Or no, this is the only one. Yeah, the king must go there. This is not as bad. The king can go here, but you can still escape. Yeah, suppose that while determining the maximum stable n, I have to ignore negative k values. And then instead of printing it, I could print a star. Well, maybe not a star. What is it? Well, it's a possibility that it's never really draw. Maybe we could print a star, meaning that black is not going to do this. But how about white is not going to do this? I think white can have bad moves, but not moves that. Well, white could do a move where they give away a rook. That's kind of the same thing. Then you have just a very quick end instead of something relative with 2n. But yeah, those are easy to spot. I'm just not going to generate those positions. That would be a position where the black king attacks the rook, so here. And then put the king somewhere where it does not define the rook, while black is to move. So that's just very specifically picking a position that is wrong in this whole block. A whole block. Well, here it's only exactly one position. This one is a very, very suspiciously low also, I have to admit. 3. But that might be just true. So let's where does it come from? This is Y to move, right? So I think that the blocking must have come from there, which is this position with black to move. And we were talking about m equals 2, so that's this one. So the best move for black is something with 11 ply. So we must, or for m is 2, we must find a position with 11 ply. Where the blacking actually moved, so not here, not here, not anywhere. Well, come on, it must be one of those. This is 7, that is bad. This must be the one, but it's 13. Strange. Yeah, so from this position to that position. The king moves there. Oh, that reduces n by 1, because the king moves there, then n is 1 less. Yep. So we go from here with 12 to there with 16, but n is to the left. That's 14 then. That doesn't work. Why? No, this one. 11, yeah. So here black is to move. Black goes 1 there, so n is 1 less. Therefore, we have to subtract 2 from this value. And then white is to move, so then we end up here. Although that says 13, really we have to subtract 1 because k has been moved that way. So that is, we go from 12 to 11. Well, 13 plus that, it's correct. Yeah, I understand it. Not that easy to read then. I was hoping to make a graph out of these things. Okay, I could still do that. It's not as trivial as I hoped, maybe. So interestingly low on MS3. Why to move? Probably just move the king here. Yep, I think I need to add positions with the rook here and then the white king there, and there. If the black king allows that. How big is this board? (20 by 10). Yeah, reasonable. Let me see if I run out of memory with 20 with 12. Blah. Yeah, starting to swap. I don't think I run out of memory, but my music stopped suddenly. OBS is still working, it seems. Still more swap. (16 GB) swap is being used now. I have a lot of tabs open though, so that just worked. Cool. And this table should be exactly the same as the other one, because we just added 2 rows on top of the board, which should not have been used. And in fact, I can do the same calculations now with M is 7 and 8 as well, I think, because we just added 2. Yeah, this should be the same as... How big was this? 20 times 12, I think. Yeah. Exactly the same. Very good. Then I can also increase the width, maybe. So I make this 10 again. Or I make this 22. Mine is 35 now. Something changed. Shit. Oh, just that one. Oh, that is actually logical. Yeah, no, of course. Yeah. Uh-huh. That is how it as it should be. And the rest is the same, so nothing changed. Really, that's good. Awesome. Okay, I'm going to do my Clash of Clan War attack. So, end of the stream. I'll be back later, maybe. Not sure.